This is the homework solution for page 193's problem 8, 10, 13, 14, 18, and 22. We have the first ones up, now 8 and 10. It asks us to determine whether each sequence is an arithmetic sequence. Write yes or no and explain. For the sequence to be a arithmetic sequence, it has to have a repeating pattern that is the same. So the common difference between each element in the sequence has to be the same value. Okay, we're going to see this. -3, 1, 5, and 9. Okay, let's find the common difference. To find the common difference, you do 1 subtract -3, right? The second element minus the first element, which is 4. Then I do the third element minus the second element, 5 minus 1 is also 4. And I do the last element, fourth element, minus the third element, which is also 4. See here that all of the common difference is 4. Therefore, I can call it an arithmetic sequence because the common difference is 4 and it stays 4 between all of them. Okay? Because the common difference is the same between each element, it becomes an arithmetic sequence. Thus, an arithmetic sequence occurs. Okay? Next, I have 10. -10, comma, -7, -4, and 1. Let's find the common difference. -7 minus -10 is 3. -4 minus -7 is 3. Looks like it should have the common difference. Let's do the last one. 1 minus -4, that becomes 5. You see, you have to check all the you have to check that all the elements have the same common difference. Here, the common difference between the first and the second term is 3. The common difference between the second and the third term is 3. And the common difference between the third and the fourth, okay, the elements, is 5. I wouldn't use the word element and term interchangeably because they are the same thing. 3, 3, and 5, the common difference is not the same. Therefore, you would say not an arithmetic sequence because there is no common difference. Okay, not an arithmetic sequence. Good. Next one. They say find the next 3 terms of each arithmetic sequence. So all the sequences here will have a common difference because they are already arithmetic sequences. So all these elements in this sequence will share a common difference. 12 minus 6 is 6. 18 minus 12 is 6. And 24 minus 18 is also 6. So the common difference here is I'm adding 6. I'm adding 6 to go from one element to the other. So 6 plus 6 is 12. 12 plus 6 is 18. 18 plus 6 is 24. So I have the chart here. To find the next 3 terms, apply the common difference. So I have the chart here. The first term is 6. The second term is 12 because I'm adding 6 to 6. Third one is 18. Fourth one is 24. The fifth one, I have to add 6. 24 plus 6 is 30. Add again 6 more, becomes 36. And last one, 36 plus 6 is 42. Okay, so this would be my next 3 terms of the sequence, 30, 36, and 42. 14, 21, 19, 17, and 15. Let's find the common difference. -19 minus 21 is -2. 17 minus 19 is -2. And 15 minus 17 is -2. The common difference here is -2. To find the next 3 terms, I have to apply the common difference of -2. So I have my terms here. The first one, again, was 21. Second one is 19. Third one is 17. The fourth one is 15. I am applying the -2 to each term. 15 plus -2 is 13. 13 plus -2 is 11. And 11 plus -2 is 9. Okay, so my next 3 terms are 13, 11, and 9. Next, it asks us to write an equation. That's the key part here, is writing an equation for the nth term of the arithmetic sequence. Then graph the first 5 terms in the sequence. I have the first 5 terms, -3, -8, -13, and -18. The first method, I'm going to show two methods on how to write this equation. The first method is using the arithmetic sequence formula. I just labeled some information here. N is your term number, A1 is your first term. Our first term is -3. The difference here is -5. How am I getting that -5? -8 minus -3. Okay, I can even write that out here. Let me show you. Right? -8 minus, boom, -3. This is equal to -5. Good? There you go. Here's the equation. This is given. You have to just memorize the equation for you to use this method. Make the substitution. Do you see A1 is -3? -3 here. The n, I don't know, so I just leave it n. The common difference is -5, so I substitute -5 there. Distribute. -5 times n is -5n. -5 times -1 is +5. Combine like terms. -5n is right here. Then +5 minus 3 is 2. Okay, here you go. An is equal to -5n plus 2. Next, the second method is to use my linear equation. Okay, what I did here, let me show you here. So right here, I wrote, this is -3, -8, -13, and -18. This is your first term, second term, third term, and fourth term. My first term is -3, the second term is -8, 3 is -13, and 4 is -18. Okay, the first thing is to do is find the common difference, which is -5. -8 minus -3 is -5. Okay, so from one term to another term, it's -5. That is the common difference. The common difference is also referred to your slope in your linear equation method. That's why I made the slope -5. Okay, these little bad boys here are the same thing. Okay, next I find the y-intercept. So this is 1 is -3. So to find the y-intercept, I have to find what happens when you get 0. Okay, so from -3 to become -8, I subtract 3. So to go backwards, I add 3. No, sorry, from -3 to -8, you subtracted 5. You added -5, right? So to go backwards, right? This becomes a 2, I believe, right? Okay, does that make sense? Because 2 plus -5 is -3. Do you see how you go from here to here by adding -5? Okay, so the y-intercept here is 2 because this is 0, 2. Okay, next you put it into the equation format. Y equals mx plus b. Your slope is -5, and your y-intercept is 2. Notice that this and this are your same thing. The only difference is that it has an x here and it has an n here. Okay, same thing. Term number, right? X here, same thing. It's the same variable. Good. Next, I think it asks me to graph. So this is very beautiful because once I have it in my chart, I can graph it. Here I have Excel, and let me just put in my terms here. I have 0, 1, 2, 3. How many terms do I have? And 4. From the 0 term, I have 2. The next one, I have -3. And after -3, it's -8, -13, and -18. Okay, for me to graph it, here, let me turn this. I select this, right? Do you see how I select my data? Whoop, that was bad right here. Select the data, insert, right? Insert, scatter plot, select scatter plot. There you go. Okay, you could write the axes if you want. Okay, here, click on the data point, right click, add trend line, display equation on chart. There you go. I can even make the chart for you a little bit bigger. Do you see that? There you go. So I can copy here, and I can display it right here. That is how it would look like. Okay. There you go. That is your graph of this model. Do you see how this scatter plot will produce a linear equation exactly like this? Or if you remember from your scatter plot, given this scatter plot, there exists a line of fit that has this equation. Good? So you should notice that this is all coming together as sort of the same idea. Okay? Arithmetic sequence, your scatter plot, line of fit, and your linear equations are all connected. They're one thing. Okay? Next. Okay? It says the amusing park scenario. Sharon and her friends spend the day at an amusing park. In the first hour, they rode 2 rides. After 2 hours, they had written 4 rides. They have written 6 rides after 3 hours. 1. Write a function to represent the arithmetic sequence, and B. Graph the function and determine its domain. So, I put it in a chart format, right? The first hour, you rode 2 rides. Okay? Second hour, you rode 4. Third hour, you rode 6. So, how much did they ride in 0 hours? Okay, it looks like they wrote 0 hour. They wrote no rides because it was 0. Do you see? You see how it follows a linear pattern? There's a common difference. There's a slope. There is the same rate of change. From 0 to 2, it's 2. From 2 to 4, it's 2. 4 to 6 is 2. So here I should have the common. I should have it somewhere here. Okay. Oh, the common. Let me. Here's the equation. The common difference here is 2. Whoop. Good. There you go. Common difference here is 2, which means the slope m is also equal to 2. The y-intercept 0, 0. So the y-intercept here is 0. Good. This is the y-intercept. Now you just plug into your equation. What is your equation? Let me just grab that equation from the last one. Here's my equation. Let me make the substitution. 2 is, m is 2, b is 0. That would be my equation. Good. Next, they asked me to graph to determine it. So let me just bring up my Excel sheet. Open up another sheet. Okay, the terms are 0, 1, 2, and 3. 0, 1, 2, and 3. Let me zoom in so you could see it a little bit more. Do you see that? 0, 1, 2, and 3. For 0, it was 0. For 1 was 2 rides. For 2 hours, it was 4 rides. And 3 hours is 6 rides. Good. Select the data points. Insert. Scatter plot. Here you go. Click on the data, right click, add trend line, hit right here on the bottom. I don't know if you can't, sorry, you can't really see it that well. Right here, right, it's your middle box. It says display equation on chart. Hit close. You should have the equation right here. The reason why, in theory, there's like a +0 here, but they don't really write that. Okay, right, copy here. There you go. That is your graph. It asks us to determine the domain, right? Remember from our vocab, the domain is referred to as your values of x you can plug in. Okay? Again, so think about what values of time you're allowed to plug in. Can you plug in 1.5 hours? Yes. Okay? Can you plug in 2.9, 3.4, or do they have to be whole numbers? It's time, and time is continuous, so you could have 1.5 hours. So the domain is all positive values. There you go, right? 2.4, 5.9, any number, irrational, rational, doesn't matter. Okay? It just has to be positive because time is always positive. You can't have negative time. Okay, there you go. That is the homework solution for page 193.